Hello, everyone. In this video, we're going to talk about identifying functions. We'll first talk about what they are, some vocabulary, some other forms of looking at them, not only with graphs, but like you see here, what's known as a mapping diagram. And then we'll talk about some strategies that you can use to identify what is a function and what's not a function. And this is all a precursor for us eventually learning how to graph what are known as linear functions. All right, so right away on this page, we see a lot of vocabulary. The notes are in blue here. If you would like to jot them down for reference later on, it's probably a good idea if you like to pause and copy the blue notes down. I'm just going to go through a kind of line by line here. So first, the word function, which is the title for today. A function represents a unique relationship between input and outputs. Now, when we talk about our graphing world, when we talk about inputs and outputs, we're talking about x and y values. So a function is this type of relationship between x and y values. What it specifically is that each input produces exactly one output. So in other words, each x value is only connected to one other y value. We can't have an x value that, for lack of a better phrase, repeats. We can't have multiple x values within the same function that have two different y values, let's say. Now, I'm going to skip down a little bit where it says vending machine analogy. The first time you hear this, if you've never learned what functions are before, this can be a little confusing. So thinking about a vending machine might help you understand what functions are and how they operate. Think about when you go to a vending machine, you may hit a button and it produces, let's say, like a bag of chips. Now, if you were to press a button and two different things were to come out, while that might be enjoyable for you, that would one, not be possible, just like it's not possible for a function to exist where one input produces two different outputs. We have to have this like one-to-one correspondence. One x value goes with one y value. Okay. There's a few other similar analogies you'll see in textbooks and things like that, but I think the vending machine one works best. The idea that hitting a button produces one outcome, just like one x value produces one y outcome. Now, some vocabulary terms, I should say, domain and range. This one might be a little bit more familiar for you. I think in the past you might have covered these words before. We're not talking about range like the statistical category, like max minus min range. So differentiate that for a moment. But domain and range refer to the x and y values. It's another way of saying domain are all your x values, range are all your y values. A little trick to remember that, alphabetical order. What do I mean? What we talked about with coordinates, x comes before y, and with domain and range, d comes before r. So if you're having trouble remembering, some people forget, oh, domain is x or y, or range is x or y, I'm forgetting, just think about alphabetical order. X comes before y in the alphabet, just like D comes before R in the alphabet. Now on the very bottom, anything that we consider that's not a function, we'll talk about how we can, identify failures and things like that later on. But something that's not a function, we call a relation. There's still a relationship between the variables, they're just not a function. Now we see three different representations on the bottom of this slide. And these are the three main ones that we'll be seeing throughout this lesson. A table of values. You might have seen this before when we do like proportions and stuff. We have one column representing, let's say, x, and then traditionally, I know it says f of x right now, but this would be something like y in the second column. Now notice here, this table happens to be a function. Why? Based on the very brief definition we've talked about so far, notice that each x value is unique. I don't see, like, for example, if I saw like a 7 here and then another 7 over here with a different number, that would go back to our vending machine, right? I would have two x values with two different y values. That's not a function, that's not allowed. Okay, but this is unique. Each x value is connected to exactly one output, one y value. Now, the middle one is probably the most, I don't know the phrase to explain that. Like, you're not familiar with this. It's called a mapping diagram. It's basically like sometimes they're like these ovals, and they're literally arrows connecting the different values. Basically, it's like a table where they don't have to be next to each other. Because if you notice here, this is saying 0, 1 is a coordinate. In a traditional table, they're kind of like left and right next to each other. So it's like a little bit less organized table. Now, this mapping diagram is actually not a function. See if you can figure out why. I'll give you a hint. It's not because there's two arrows pointing at one. That's actually allowed. You can have an output be repeated. Just like you can maybe have like two different buttons that are both like Lay's potato chips, right? That's possible. What's wrong with this is this right here. This X value of -35 is corresponding to 1 and 22. So this breaks this definition right here. There's an input that has more than one output associated with it. Okay, so this is not a function. The mapping diagram in the middle, not a function. Has more than one output associated with it. And last but not least, we're going to look at graphs. For that, we have something known as the vertical line test. Graphs are actually the easiest to spot once you know what the vertical line test is, and we'll talk about that on the next slide. All right, and we're going to practice with this idea. Sometimes it's almost like more confusing to explain it in the definitions than to actually do a problem where it's asking you what's a function or what's not a function. So we're going to look at the example at the top here. We're given sets of different points. These are all relations right now. They're just like basically a collection of 3 or 4 different points, and I want to know which one is a function. So let's go through them choice by choice. Right away in choice 1, I see there's a point 0.03, and then there's another point 0.06. So this is that example of x quote unquote repeating. There's an x value that's associated with 2 different y values. That's not a function. That's your hitting a button on a vending machine and then chips and a candy bar come out at the same time. While that would be awesome, that's probably not possible, not a function. Okay, for choice 2, we see -7, quote unquote, repeat. It belongs to 5 and it also belongs to 1. So there's one input connected to 2 outputs, not a function. This part of it's actually okay. This is always the confusing part. The fact that you see like 3 and then another 3, that's actually fine. Y is allowed to repeat. Every single Y value could be 3 for all we care. That's perfectly fine. That'd be like a vending machine where every single option is chips, right? We're allowed to repeat the outputs. It's the inputs that can't repeat. Okay, choice 3, I see 6, 2 and 6, -2. So one input, 2 different outputs, not a function. And just by process of elimination, it looks like it's going to be choice 4, but let's see. Each input, -6, -3, +1, and +6. Each input, or x value, is unique. Okay, there's no repeating x values. It's okay that I see 2 2s. Remember, like we said, the outputs can always repeat. It's the input, it's the x values that's really going to determine if something is a function or not a function. Also remember some vocab here, domain and range. So if this question asks like, hey, once you find the answer, what's the domain and what's the range? Domain are your x values. So I would say -6, -3, +1, and +6. And range are your y values. So I would say 2 and 5. There's only 2 different y values. You don't have to write them twice. You don't have to write like 2, 2, 5, 5. Domain, x values, range, y values. Okay, so on the last slide I mentioned something that's called the vertical line test. Basically, this is a quick way of telling if a graph is a function or not. So, first you have to know what a vertical line is. A vertical line is, think about like laying your pencil flat on the paper. Sometimes textbooks will call this like the pencil test. A vertical line is an up and down straight line, perfectly straight. And basically how the vertical line test works, if you're able, and you don't literally have to do this, it's more so like talking about like imagining mentally. I know I'm able to do it with some of the tools on my iPad here. But if you're able to imagine a vertical line that can touch the graph at more than one spot, it's automatically not a function. It's what they say, we like to say, it fails the vertical line test. So see how this green line here touches this circle here and here? It's hitting the graph in 2 spots at the same time. This is not a function. And vice versa, if we're able to imagine a vertical line that will only touch the graph once, no matter where we put it, then it is a function. So like choice C, this diagonal line, no matter where I put it, how many times is my green vertical line touching it? It's only touching it once. So this passes the vertical line test, and it therefore is a function. Now, if we look at choice A, it's called a quadratic or a parabola. You don't need to know that. No matter where I'm sliding this line, this vertical line, again, this is kind of you imagining this. You're never going to actually do this. But no matter where I put it, it's only hitting once, so this passes as well. This is a function, so it passes the vertical line test. If you're ever asked to explain, that can be a reason. You could say it passes the vertical line test. And for choice D, that's an exponential function. It passes as well. No matter where I put that vertical line, it's only touching once. All right, for this one, we're going to look at different representations, and we're ultimately going to see which of these four are functions. For some reason, it is a little blurry, so if you can't see anything, I'll try to read out some of the things on the bottom there. But for number one, we're going to look at a table of values. Right away, I notice that there's a 2 up top and a 2 on the bottom. So that's one input, one x value, that has two different outputs. 2 is connected to 6, and 2 is connected to -6. As we've learned, this is not allowed. This is not a function. That's your vending machine example, hitting one button, two dings coming out. For choice two, wrong tool. For choice two, we have a set of points. The x values we have 1, 2, 3, 4, 5, 6, 7. So no x values repeat. This is actually good. Is it a problem that you may be noticing that you see a 1 here and a 1 here? That's perfectly fine. Y is allowed to repeat. Every single y value could be the same in a set of like 10 different points. Every y value could be 1, and it wouldn't be a problem. Y is allowed to repeat. It's the x value. It's the inputs that we want to be unique. The domain values, the x values, whatever you want to call them, those are the ones that have to be unique, are only allowed one partner. For number three, we're going to think about our vertical line test. I'm just going to sketch one here. Right away, I could see this is going to fail the vertical line test. It hits the graph more than once. Some people get confused because they're like, hey, it's passing over here, or passes right here. It looks like it only touches once. It's if you can find any spot. Doesn't matter if it passed for 90% of the graph that you see. If you can find any spot where it fails, it fails. So this is not a function. A vertical line touches it more than once. No good. And for choice four, I'm going to kind of table for now because we haven't quite learned this just yet. This is actually a screenshot question from a Regents exam. Choice four is an equation. If you want to think of it this way, no matter what x value you plug in, let's say I plug in 5 for x. What do you get for y? 2 times 5 plus 1, you'll get 11. There's no way for you to ever get, two different values for plugging in one thing. So this is actually going to be a function. So 2 and 4 end up working. And again, don't worry too much about 4. I'm kind of glossing over it for now. But ultimately, in the coming lessons, we're going to learn how to graph something that looks like choice 4 by making a table of values, by talking about things like slope and y-intercept. We'll actually see what this looks like, and that could be another way to explain why 4 was a function. I'll do a very rudimentary example right now, but choice 4 would look something like this. Stressing the word rudimentary. It would be kind of like a diagonal line. So based on what you've learned so far, you know that this passes the vertical line test. All right, we're going to jump right into some other practice questions. For number one, which graph is not a function? So this is our vertical line test whenever we have graphs. For number 4 down here, it looks like it's passing everywhere, so 4 can't be our answer. We're looking for the one that's not a function, or the one that fails the vertical line test. This is also going to pass. This is going to pass. It's going to be choice 1 as our answer. It's a little steep. If I make the line kind of skinny, you can see it. It's hitting more than once there, and the same thing's going to happen on the other side. So there's a spot where vertical line would hit the graph more than once. Basically, the vertical line test is a way of like a visual way of looking at the x repeating idea. But choice 1 is going to be our non-function. Okay, for 2, we're looking at 4 different tables. Don't panic too much just yet when you see this. Basically, for now, think about it like it said y, x and y. That's read as f of x. It's another way of saying y. So which one is a function? Choice 1, no good, 2 and 2. Choice 2, no good, 0, 0. Choice 3, 3, 5, 7, 9, that is actually good. And choice 4 fails as well because of 0, 0. So choice 3 is our answer, the table that works, the one where we don't see any x values that repeat to 2 different y values. And last but not least, if included in the table, which ordered pair, -4, 1, basically which coordinate, or 1, -4 would result in a relation that is no longer a function. So basically like it's a 50-50 here. Which of those points would make this not be a function anymore? So it's going to end up being, you could flip a coin if you're really not sure, I guess, but it's going to end up being -4, 1. And I'm going to explain just verbally rather than writing it down. Why would -4, 1 make this if I inserted it into the table? So like if I added another row and I wrote this, why would this make it no longer be a function? Because I already have a -4 up here for x. So if I have another -4, this one goes to 1, this one went to 2, that's one x value, one input that is corresponding to 2 different outputs, not a function. One -4 would be perfectly fine. One -4 would be allowed because there's no other x value of 1. So that's perfectly fine. What they're trying to get people with there is the -4 idea because -4 does repeat in the y column, but like we've said a few times, that's perfectly fine. And that's going to wrap up our lesson on identifying functions. I know this can be a little confusing. If you had a little bit of difficulty with one particular part, I definitely recommend, I don't know if you guys do this traditionally, but maybe rewind something or just rewatch it briefly, or if you want to like copy some of the notes down, if you don't usually do that, it can be a little tricky. But when you actually do the problems, if you really understand it, these questions are actually pretty easy once you understand the concept. There's not a lot of like math to quote unquote do. And again, this is all a precursor to us ultimately learning how to graph. I know it doesn't seem like it just yet, but if we're going to be graphing functions, it's important that we know what functions are and what they're not. So thank you all for watching. Have a great day. Let me know if you have any questions. Take care.